S2 is a star in the star cluster close to the radio source Sagittarius A star. It orbits our central black hole with a period of slightly over 16 years, which is slightly longer than the planet Jupiter takes to orbit the Sun. But that's where the similarities end. While Jupiter is just 5 astronomical units from the Sun, S2 has a highly elliptical orbit with a semi-major axis of about 970 astronomical units, a pericenter distance or closest approach to Sagittarius A star of 17 light hours or 120 astronomical units. So this star comes no closer than about 4 times the distance of Neptune from the Sun. You may have deduced then that this star is travelling immensely quickly. Hi everyone, Vega here, and in today's video, complementary to an idea given to me by the What's Next channel, we are going to be looking at what may well be the very closest star of all to the centre of our Milky Way galaxy, S2. So let's get to it. While it's quite difficult to fully know, the mass when the star first formed was estimated by the European Southern Observatory, or ESO, to have an approximate mass of 14 suns. In this table, we see some very famous stars in our local area: Rigel, Betelgeuse, Antares and Spica, so we can compare the mass of S2 in perspective. S2, as we can see, is a large star, and based on its spectral type, somewhere ranging between B05 and B35, it likely has a mass of 10 to 15 solar masses, but most likely 14. Of course, we might also note that at roughly 26,000 light years away, it is completely invisible to the naked eye and has an apparent magnitude of over 14. If you're interested in massive stars, don't forget to check out the Massive Local Stars Collection video, ranking the top 20 in our local area, and I'll link it in the card above. Its changing apparent position has been monitored since 1995, and now S2 has been observed for one complete orbit. Some of these observations have been used by the Max Planck Institute for Extraterrestrial Physics to measure the distance from Earth to the galactic centre. They determined it to be between 24,527 and 27,267 light years, which seemed to make an agreement with prior determinations made by other methods. Interestingly, the highly eccentric orbit of S2 gives astronomers a great opportunity to test for various effects predicted by general relativity, and even extra-dimensional effects. These effects would obviously reach a maximum at closest approach to the Sagittarius A star. What this means is that a recent estimate of 4.31 million solar masses from the Sagittarius A star black hole accelerates S2 to the fastest known orbit, where it reaches speeds on average exceeding 5,000 kilometers a second, some 11 million miles per hour, or 1/60th the speed of light. This is reached gradually over its 16-year orbit due to an acceleration of a fairly reasonable 1.5 meters per second, which is almost 1/6 of Earth's surface gravity. The motion of S2 is useful for detecting the presence of other objects near to Sagittarius A star too. It's also been a fascination of mine that there is a possibility that Sagittarius A star is surrounded not only by thousands of stars, but also other darker stellar remnants like stellar black holes, neutron stars, or even white dwarfs. Interestingly, this was also theorized in 2003, where 2 astronomers, Brad Hansen and Milos Milosavljevic, stated that there is a probable middleweight black hole with thousands of solar masses that is dragging a cluster of young stars toward the Milky Way supermassive central black hole. This and other objects do perturb S2's orbit and cause it to deviate gradually from what we would normally expect around a single point mass. So far, it's estimated that the constraint placed on S2's orbit is that their total mass comprises less than 1% of the mass of the supermassive black hole. That is to say, that all the mass that's in the relative area of Sagittarius A star comprises less than 1% of the mass of the black hole itself. We did mention that the average speed of S2 was as much as 1/60th of the speed of light on average in its orbit, but incredibly, as the star approaches the central black hole, it can reach as much as 7,650 kilometers a second, which is almost 3% of the speed of light, as it passes by its pericenter, or closest approach, of just 120 astronomical units from Sagittarius A star. This part of the orbit was measured in 2018, and it was found to be fully consistent with general relativity. The mind of Albert Einstein is famous, but sometimes we don't take the time to appreciate just how brilliant it was. Since his death in 1955, we continue to make findings that agree even now, and presumably will continue to do so far into the future. We might wonder what a view from a planet in orbit around S2 might look like, but unfortunately, we must consider that any planet around the star would likely be completely uninhabitable. There is a lack of information to know exactly, but assuming a stellar luminosity of around 25,000 suns and a temperature of around 26,000 Kelvin, which would be about average for a B15 star, S2's star's radius should be around 8 suns. And this means, unfortunately, that it doesn't really have a habitable zone per se, because it would stretch beyond the black hole itself, so it seems relatively pointless to calculate it. In other words, any habitable planet would not actually be in orbit around S2, but in orbit around the black hole itself. And unfortunately, as we know, S2 is located in the Milky Way's hot and violent galactic centre, deep within its central bulge, and would be relentlessly bombarded with cosmic rays. Be that as it may, let's still imagine a lava world that's close enough to S2 that S2's feeble gravity in comparison to Sagittarius A star is enough to hold on to it. In a base, shielded from radiation and heat, we see the dazzlingly bright S2 star, dominating almost everything in the sky during the day. But as our world turns slowly away, we see the Sagittarius A star black hole in all its glory. An astonishing view, and perhaps at least within the Milky Way, the most impressive view of all. Despite our focus on S2, interestingly, a still closer star, S62, has since been discovered with an orbital period of 9.9 years. S62 has a highly eccentric orbit which makes it pass very close to Sagittarius A star. At only 16 astronomical units now, it's less than the distance between Uranus and the Sun. As things stand, little is known about the star, but stay tuned to the channel for an update when and if more information becomes available. This S62 star, fascinatingly, passes only about 250 times the Schwarzschild radius of Sagittarius A star. The only certainty is that any life harbouring in this most dangerous of dangerous regions in our galaxy would be nothing like any life at all we've ever known. The wonders of the centre of our galaxy are where S2 and many other stars can be found. We know that the region is incredibly inhospitable to life as we know it, but we also know that the brilliance of one Albert Einstein made predictions that still come true many decades after his death. It seems, however strange our galaxy may be, it, at least for now, seems to abide by the same rules as we do. Thanks for watching, and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider buying me a coffee, and I'll link this in the description below. Thanks to the What's Next channel for this brilliant idea for a video, and also if you have any videos or subjects that you'd like to see brought to life, don't forget to let me know in the comments below, and it could just be your idea next week that shows up. Take good care of yourselves, look after your friends and family well, and I'll see you on the next one.